and welcome to another episode of NASA Science Live. I'm your host, Lauren Ward. Sea levels across the globe are rising as a result of a changing climate, and the rates at which they are rising are accelerating. For nearly 30 years, NASA has continually been tracking the global surface height of the ocean from space in order to understand sea level rise. Rising sea level affects everyone across the globe, from coastal communities to those living in landlocked regions. Today we will dive deep and discuss how NASA and others across the globe are monitoring our oceans and what communities are doing to alleviate the impacts of sea level rise. But first, what exactly is sea level rise?
Around the globe, sea levels are rising. Greenhouse gas emissions cause our planet to warm, and Earth's oceans absorb about 90% of the excess heat. As ice melts at the poles and high in the mountains, and the molecules of ocean water expand, the seas are making their way onto land. Since 1880, sea levels have risen about 8 to 9 inches. But the seas don't rise uniformly. Some places are at higher risk for flooding, and sea levels are rising faster as time passes. Right now, sea level is rising about 3.3 millimeters a year, 30% faster than in 1992. Here at NASA, we're using satellites, like the new Sentinel-6 Michael Freilich, along with ships and airplanes, to study the processes driving sea level rise and the effects of rising seas.
Over the course of nearly 3 decades, a series of satellites have circled our planet continuously measuring sea levels. Their data have helped researchers reveal mysteries of weather phenomenon like El Niño, and have also helped researchers forecast how much sea level rise could impact our coastlines. Now, engineers and scientists are preparing to launch 2 identical satellites to add to this legacy. First, Sentinel-6 Michael Freilich, and second, Sentinel-6B launching 5 years later. Here to tell us more is the Sentinel-6 project manager, Parag Vazee, who has been part of sea level rise observations for nearly 30 years.
I see pictures of coastal inundation and flooding. What might happen in the next 100 years with the 200 million plus people who live in those low-lying coastal areas all across the globe. My name is Parag Vazee, and I do anything and everything that's needed to make Sentinel-6 project successful. Sentinel-6 is all about water. So this is a 1/3 scale model of the Sentinel-6 satellite. Sentinel-6 is a collaboration with NASA, NOAA, the European Space Agency, and also EUMETSAT in Europe to measure sea level. This sort of top half of the satellite houses the main instruments. The history behind this goes back 30 years. I've worked on Topex Poseidon, JASON-1, JASON-2, JASON-3, and now Sentinel-6. All of them are the same series of missions. It's a great feeling of satisfaction. I had aspirations right from childhood to somehow work in the space industry. I knew that I wanted to work in something that made a difference. This is the room where we developed, integrated, tested the Sentinel-6 instruments, and then right here is where we packed it up also before we shipped it to Germany. Seeing that come to fruition is a personal satisfaction and an emotional satisfaction. The importance of this project and where it touches is on all walks of life all across the world.
Parag, thank you so much for joining us.
Thank you for having me.
All right, let's kick this off. Why is it important to study sea level rise at all?
Yeah, sea level rise is an extremely important topic for everyone. Something that people have seen in their backyards with the oceans actually changing over time. It's something that people are noticing more recently, but something that people have known for a long, long time. And it affects everyday life, it affects commerce, it affects shipping, all kinds of applications where people really want and need to know what's happening on our oceans, which surround our Earth for the vast majority of the Earth having oceans, 70%.
You make a great point. It's most of planet Earth. So what will this mission in particular contribute to the effort of studying sea level rise?
Right. So sea level rise or sea level has been an important topic for people, but really understanding and quantifying what's happening with the ocean is difficult to do. It's changing slowly, but it is changing, and understanding how quickly that's changing. It requires really a measurement, a very precise measurement, and a continuous measurement. So Sentinel-6 will continue that measurement that's been established for 28 years. And what's special is really continue that over the course of the next decades with two satellites, not just a one-off satellite, but two satellites to really establish and continue that.
That's remarkable. One thing that I think is really interesting is how will it actually measure sea level rise, and how will that contribute to what we already know about sea level rise?
Yeah, so people have been interested in measuring sea level. They've been using, dipsticks essentially in the years since when ships were out on the ocean, and people were curious what's happening in living close to the ocean. But that is a difficult process to really understand what's actually happening precisely across the world. So satellite remote sensing really is a solution that allows us to understand what's happening precisely over all of the oceans across the whole world.
So I understand Sentinel-6 is an international mission, speaking of seeing the whole world. Can you speak about some of the global collaboration that happened to get this mission off the ground?
Yeah, so it's a global problem. It's a difficult problem. So it requires a global solution, and that means people from all skill mixes contributing to that. That has actually been happening with engineers, scientists, users for many, many years. But Sentinel-6 brings that together in an operational sense. It goes from taking something that's been done together and bringing all the resources and minds together traditionally for the past 28 years, and really looks towards making that into an operational service that's going to continue for the next decades or more.
Yes, as you say, global problems require global solutions, and we are doing just that. But that's all the time we have. Thank you so much for joining us, Parag.
Thank you for having me.
A satellite dedicated to uncovering new knowledge about our rising seas deserves to be named after someone who dedicated his life to understanding our oceans. That is why NASA's European partners on this mission named Sentinel-6A satellite in honor of Michael Freilich, a world-renowned oceanographer and former director of NASA's Earth Science Division. Mike's contributions to Earth science were invaluable.
My story is likely quite atypical. I knew in 10th grade that I wanted to be a nearshore oceanographer. What has driven me is understanding how nature works.
And that's why humanity, not one agency, not one country, not one continent, but why humanity has been monitoring global sea level from space with exquisite accuracy for more than 28 years.
It's a world-renowned ocean scientist who, after a successful career in academia, came to NASA, and for 12 years, Dr. Mike Freilich led all of Earth science.
And he's really brought NASA back on the international stage.
And this is not all. You also changed the discipline of Earth science in a profound way, combining science and technology to understand our beautiful planet.
Mike Freilich's legacy is being able to build the coalitions that are necessary for us to get as much understanding of our planet as possible. There is not another person more deserving of this honor than Mike Freilich.
I'm very pleased to rename Sentinel-6A in the future to be called Sentinel-6 Michael Freilich.
You know, when I first found out that Mike had cancer, I want him to know that all the work he's done is extremely meaningful.
I am much better because of what I learned from him and because I had the opportunity to work with him.
Mike is a leader to all of us and a mentor and a person who has really advanced earth science for the entire world.
He was absolutely committed to dispassionately following the science.
He had high standards for himself and everyone around him.
We're able to raise the bar of what we can expect from ourselves, from our partners, and from our larger global community.
Mike had a very big, very full red pen. Everybody was always afraid of that red pen.
His pretty intense energy. One of the characteristics was the bouncing knee, which you never missed, and it was always there, and you could kind of gauge the way the meeting was going by the pace of the bounce.
I have a lot of hilarious emails on my smartphone exchanged with Mike, which I keep as a treasure.
It is a no-brainer that we all came together and that they were able to really rally around and allow the renaming of Sentinel-6A after Mike.
Earth system science is bigger than any particular agency. It's bigger than any single nation. It's bigger than any single continent. And I surely hope, because humanity requires it, that we make some significant progress in understanding.
You did good, Dr. Freilich, for all of us, and for that we're all very grateful.
Mike Freilich was a leader in earth science who believed in fostering international partnerships to improve our understanding of all Earth systems, including our oceans. Let's get to know some of the people behind this truly international mission.
This is this big, complex machine that we're trying to understand.
We really need to understand how it's changing. How is it evolving?
Wherever you live on this globe, the oceans will influence you in some form or the other.
We are answering those really interesting and hard questions that we all have about our universe and our planet.
My name is Séverine Fournier, and I'm observing our changing oceans from space.
I'm Shannon Statham, and here at NASA JPL, I help prepare Sentinel-6 for its journey to space.
My name is Shailen Desai.
My name is Parag Vaze.
My name is Ben Hamilton, and I'm studying sea level rise from space.
We're looking at a 1/3 replica of the Sentinel-6 Michael Freilich satellite.
Sentinel-6 is all about water. This sort of top half of the satellite houses the main instruments.
We have the altimeter, we have the radiometer.
Sentinel-6 is a collaboration with NASA, NOAA, the European Space Agency, and also EUMETSAT in Europe to measure sea level.
And it's specifically capturing the height of the ocean.
The satellite is actually emitting a signal.
And that signal is bouncing back.
It measures the time it takes for that pulse to get back.
So we've been measuring the height of the ocean since the beginning of the 90s.
I've worked on Topex Poseidon, JASON-1, JASON-2, JASON-3.
We really need that long duration observation.
And Sentinel-6 is going to allow us to continue that record.
So that we can better predict what is the rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It's not just scientific curiosity, it really impacts the daily lives of people and their ability to plan for their future.
I see pictures of coastal inundation and flooding.
You start to realize the importance of understanding what sea level is doing now. We can use that understanding to know what sea level might be doing in the future.
Seeing that come to fruition is a personal satisfaction and an emotional satisfaction.
Scientists around the world are using this data to help people.
The importance of this project and where it touches is on all walks of life all across the world.
From space, it's just one planet.
Sea level rise is a direct result of climate change. As ocean temperatures increase, our global ocean expands. As ice sheets and glaciers melt, they add more water. But climate change has many impacts beyond sea level rise. We're joined by Dr. Ivana Cetinich, an oceanographer at the Ocean Ecology Lab at NASA's Goddard Space Flight Center. Thank you for joining us, Ivana.
I'm happy to be here, Lauren.
Always happy to have you. So we know that sea level rise is increasing the height of the world's ocean, but can you tell us about some of the other things that are happening due to climate change?
For sure. So ocean and climate are very interlinked. Ocean is part of the four systems of Earth, and each of them kind of have like a little thing that they're doing, and they're very interlinked through the exchange of water, carbon, or energy. And so if one kind of fails, the other one comes to help. And ocean's helping a lot and trying to control the climate change. But there's different aspects of of different processes that are happening in the ocean that we can see as a result of climate change. First one is the increase of temperature, both in the sea surface and internal portion of the ocean all around the world. Then we have disappearance of the sea ice, mostly happening in Arctic region. Then we have the sea level rise that is impacted by these two processes that I mentioned before, that is seen all around the coasts, all over the ocean. And ultimately we have ocean acidification, which is a process that's happening because the carbon dioxide from the atmosphere is melting in the ocean, is changing the acidity of the ocean. And all these things together, in a sense, are impacting the way that the physics, biology, chemistry, and geology of the work of the ocean is working. And then ultimately it impacts us.
So what I'm hearing from you is that it's a very complicated system.
Yeah, and very intricately connected.
Wow, yes. So I think one thing that people might find surprising is that, NASA has a suite of tools that it uses to study the ocean, and it's not just satellites. Can you tell us about some of those tools that we use to monitor the ocean ecosystems?
For sure. So as an oceanographer working at NASA, I always get like, what?
Yes.
But NASA does study Earth, and NASA does study oceans. So first we have satellites, and there's this whole fleet of NASA Earth observing satellites, and some of them are actually looking specifically at the ocean and give us this continuous synoptic view of the ocean's behavior in a sense. It talks about physics, the temperature, or biology. And biology is really cool because it looks at these teeny tiny phytoplankton, which are like teeny tiny plant-like organisms in the ocean. And I'm working on one of these missions that's going to be launched in a couple of years. It's called PACE, which stands for Plankton Aerosol Clad Ocean Ecosystem. And that one, among other things, will look at the diversity of that phytoplankton, these teeny tiny creatures. So you have the satellite. And then we go on field. We use aircrafts, we use research vessels, we use moorings, robots, field stations to kind of focus on specific questions, specific areas. And then ultimately we take all that data and plug it into the models, such as big Earth system models that can really allow us to understand this interaction between the ocean and climate, ocean ecosystems and climate, and then actually predict what's going to happen with the ocean ecosystems of tomorrow.
Wow, that's amazing. I love that vision of seeing, planes in the sky, satellites,
like,
boats on the water, everything.
Yeah,
you got the
everything
whole
coming
suite.
together.
Exactly.
Yeah, it's pretty awesome.
It's amazing. I want to dig into that a little bit deeper. What changes are we seeing to ocean ecosystems due to climate change? This sounds like it's something that's kind of in your wheelhouse.
Yes. So, when you mentioned sea level rise, and that's the first thing that people think about, changing oceans. And that's felt along the coast. Like 40% of the people in the US live along the coast, and that's where you feel it the most. But ocean has ecosystems, and all these ecosystems, although hidden from our eyes, they're there, they're present, and they're changing. So thanks to the NASA Earth observing satellites, we can see these changes. For example, there's these portions of the Earth that we call oceanic deserts, where the number of these phytoplankton are really low, and they're actually extending over the last decade or so. So we know that. Then we go back to the field and we use vessels, and we see that the types of phytoplankton in these ecosystems are changing. Some of them are actually moving polewards, kind of like towards, let's say, north. And so now, how does it affect you? I'm like, you live on the coast, you don't care about open ocean. Well, that phytoplankton is food for something. It's actually food for everything in the ocean. It's food for the fish. They will ultimately end on your plate. So these changes in the ecosystem, although you're not on a coastal area, will eventually affect everybody on Earth.
Yeah, everything's got to eat, right? That's
exactly.
That's kind of a hard and fast rule. So what strikes me, Ivana, is that a lot of this news is kind of discouraging. You work with data that can be very dark. What do you do? Why do you continue doing this work? When the news that you're getting constantly is unhappy often.
Yeah. So, you get lots of data when you're working in NASA, and you're surrounded with amazing scientists who know much more than I do. And all that stuff is discouraging, definitely. But there's two reasons why I keep on doing it. First, this is our home. This is the only home we have. There's no other planet that we know of that contains life or on which we can live. Exactly. And the second thing, I do have a teeny tiny bit of hope in humanity that will change its ways and, kind of like probably, hopefully, change the path that we're currently taking in regards to the climate change.
I think we all are holding on to that spark of hope, and that's why we do what we do. But thank you so much for joining us, Ivana. We loved having you.
I'm super happy to be here.
Real-world impacts of our rising oceans can be seen in coastal communities like the Hampton Roads region in southeast Virginia. Let's take a look to see how sea level rise is directly affecting their community and how they are using NASA data to help forecast future impacts.
Sea level rise is a measurable difference in water level over time, and directly contributing to that is, of course, climate change. So as the temperatures rise, polar ice caps melt, and slowly the water level rises all throughout the globe. And there are localized impacts of sea level rise.
In Hampton Roads, we are particularly vulnerable to coastal flooding.
The Hampton Roads region of Virginia is the second most heavily impacted region in the United States when we talk about sea level rise, after, of course, New Orleans.
We're standing here at the Hague, part of Norfolk, Virginia, which is in the mouth of the Chesapeake Bay in southeast Virginia. This area will see what we call blue sky flooding quite regularly, where there's no storm event. And so this water comes up over onto this side, water breaches the bulkhead, floods the area around it and the road behind me as well.
A lot of my research, the Virginia Institute of Marine Science, involves the development of physics-based hydrodynamic models. These models tell us where flooding is going to happen before it does, when, and for how long. But you'll see all these individual structures here, most of them near the waterfront are inundated. The information provided by NASA satellites mostly allows us to validate the accuracy of our model in terms of telling us where the flooding actually happened from space.
The maps that come out of the models are really useful at showing the depth of water throughout the city at the street level so that we can, just make better data-driven decisions around the city.
These are two standard active remote sensors.
This is an example of a pressure transducer water sensor, and what we've been trying to do is compare data like NASA satellite imagery to see how it compares to the accuracy that we're getting at the street level. So when you put it all together, it's very valuable.
One of the main applications is really trying to see, before these events happen, where are going to be the problem areas in our communities.
Determine what roads need to be closed or intersections need to be closed when.
Where these projects should be permitted. Will this building last the 30-year life of the standard mortgage? Our models, as a representation of reality, have to be as accurate as possible. The additional information from the NASA satellites, Landsat, Aster, and MODIS, really helps us calibrate our model.
Having that regional water depth map really helps us in kind of understanding what the future day-to-day looks like in Norfolk with sea level rise.
And so better understanding sea level rise will help you decide places where you may wish to work or live in the near future. It also helps you better understand specifically what your risk is inherent, not just with flooding, but also with the changes to our climate as our world continues to change, either for the better or worse.
From the vantage point of space, we are able to monitor and see changes across our planet and compare data over time. Joining us now is Dr. Nasser Sha'at, SWAT Payload Systems Engineer Lead, who's going to tell us more about how we study oceans from space. Thank you for joining us.
Thank you for having me.
It's a pleasure to have you. So let's get into it. We know that NASA uses satellites to study our planet, but could you give us a better idea of how these spacecraft actually work, specifically Sentinel-6 Michael Freilich?
Yeah, so NASA has a wide range of Earth science satellites that actually study Earth in very different ways. But first, I would like to start by saying that we're not relying on optical measurements because they can be impaired by the weather conditions or even by clouds or whether we're the day or night. So instead, we're mainly using microwave instruments which are not being affected by these conditions or whether it's the day or night. So Sentinel-6 specifically uses two main instruments. The first one is the altimeter, which is an active instrument. Active instrument means that it actually transmits power. Passive instrument means that it's only looking at what's coming at it. So the altimeter actually sends a pulse. The pulse goes and bounces back the surface of Earth and comes back to the instruments. So we know the precise orbit of the satellites, and we also know how long it actually took for this pulse to travel back and forth. And so we can actually extract the surface height by doing so. However, it's a little bit tiny, more complex than that, because this pulse can actually be slowed down by the atmosphere. So as a result, we have a radiometer, which is a passive instrument that is only looking at specific frequencies and power coming at it, which allows us to know how this pulse is being affected. So that allows us to calibrate the result that we're getting from the altimeter, allowing us to get a very precise measurement of the surface height. That's how Sentinel-6 works.
Wow. I hear that and just think we've got a lot of incredibly smart engineers working for Team NASA, yourself obviously included. So one thing that I thought about, and maybe others have thought about this too, is that if the ocean is constantly moving and constantly changing, how are we able to capture accurate measurements?
That's actually a great question, and my friends consistently ask me the same question. So trying to answer that question all the time, I realize that it's because people have in mind the fact that we're looking at a single point. So if you're looking at a single point that is constantly moving, so of course it makes it very difficult. However, what the altimeter is actually looking is a footprint on the ocean that is actually quite large, several kilometers. So as a result, small variation as a result of waves and things like that will not really affect this result, since we're averaging over such a large area. And also I should add to that the other spatial temporal resolution is really what we care about. So Sentinel-6 will be able to cover the entire map, actually 95% of the map of the globe every 10 days. So we'll be able to get this data point every 10 days for a duration of the mission, which is 5 years until the next satellite goes, and it's going to be 5 years at all again. So the scientists are looking at a very changes over a large amount of time, so many years.
Right. Yeah. So it's not just about one wave at one moment. It's about, the big picture over a long period of time on an average. Yeah, that makes total sense. So now I want to talk about something that's probably very near and dear to your heart. We've been talking a lot about NASA's next ocean monitoring system, Sentinel-6, but I understand you're actually working on a new Earth observing mission called SWOT. And before we get into you telling us what SWOT is about, can you actually tell us what that acronym means?
Yes, so SWOT means Surface Water Ocean Topography. And topography is a fancy word to define the study of the shape of what we're looking at. And so the way SWOT works, it's basically, we're using the same instrument that Sentinel-6 is using. So there is a large heritage from Sentinel-6 and the JSON series satellites. But on top of the altimeter and the radiometer and all the instrument to provide a precise orbit measurement of the satellite, we also have a very, very fancy radar. I'm not going to go into the details on how this radar works, but what you need to take out of that is that this fancy radar allows us to get inland measurements. And also, for the first time, that's going to be the first time a satellite will be able to get inland water measurements.
That's huge.
Yes. And also, it will be able to give us information about the currents on the ocean. And on top of that, will give us a better range resolution and discrimination of few meters. So we're pushing the limits of what we're capable of doing with current satellites every time. So satellites is a good example of that. We're always pushing the boundaries of what we can do.
Well, you heard it here, folks. Our team is producing the latest and greatest with whatever they do, and right now it happens to be an amazing ocean monitoring system. But that's about all the time we have. Thank you so much, Nasser, for joining us.
Thank you for having me. My pleasure.
And thank you for joining us at home. If you would like to learn more about our global ocean and sea level rise research at NASA, please head over to sealevel.nasa.gov. For more information about the Sentinel-6 Michael Freilich satellite and sea level rise, and for ways to watch the launch with us, follow @NASA Earth on Twitter and Facebook. Until then, we'll see you next time.